Today we're going to learn about sample space. Our outcome is I can determine the sample space for a given experiment and to determine which member of the sample space are related to certain events. So why do we need to learn this? A coin is tossed in sporting events to decide which team starts with the ball. It's the only way for it to be fair. If you toss a coin once, there are two possible outcomes. You're either going to get a heads or a tails. So I need you to draw your line down and let's write this in our notebook. These are the three vocabulary words you need to know. First of all, outcomes. Outcomes are your results. So based on this above, your outcomes would be a heads or a tails. Events. The thing that is happening in the probability experiment. In the case above, it's the flipping of the coin. Sample space, then, is a list of all possible outcomes in a probability experiment, and that's what we're going to be doing today. We are going to be making an organized list of all possible outcomes. So let's find the sample space. It says use the menu. Construct a sample space for selecting a main dish and a side dish. How many possible outcomes are there? So you not only need to find out how many, but you need to list them. So there's some shortcut ways to do this. For instance, let's take a look. If I want to find the main dish as grilled chicken, I would go with salad, with vegetable, and rice. No, we are not drawing a line. You have to list them out. So I'm going to use G for grilled chicken and S for salad. So that's one option. Grilled chicken, veggies would be a second option, and grilled chicken and rice would be the third option. Again, make sure you list them out. So another option would be the baked chicken in the salad, the baked chicken in the rice, or the vegetables, and the baked chicken in the rice. So you'd go baked chicken salad, baked chicken vegetables, and baked chicken and rice. And now you would say I have 1, 2, 3, 4, 5, 6 possible outcomes, and you're able to see which outcome they are. So you're going to try this next. So a bicycle shop comes in 3 models. So let's use model 1, M1, M2 for model 2, and M3 for model 3 as our abbreviations. And 3 colors. Again, we'll use C1 for color 1, C2 for color 2, and C3 for color 3. You're going to try to construct a sample space, so you need to list them out to find how many bicycle choices you have. So then you need to tell me how many possible outcomes there are. Stop the video now and try this. All right, so let's take a look. You need to have them listed out. So model 1 would go with color 1. Model 1 with color 2. Model 1 with color 3. So now we'd have to go model 2 with color 1, model 2 with color 2, model 2 with color 3. And then we would go model 3 with color 1, model 3 with color 2, model 3 with color 3, which would give us 9 possible outcomes. Another way to create an organized list is a tree diagram. Again, it gives us an organized list of possible outcomes without having to list out each one individually. So if you roll a standard number cube and then toss a coin, list the possible outcomes. So the first thing I'm doing here is I am rolling a number cube. So I have to think of all the outcomes on a number cube. That would be 1, 2, 3, 4, 5, and 6. And then I have to think of, okay, how many outcomes do I have when I toss a coin? I have 2, a head and a tail. So we say there are 2 outcomes. Now what are those 2 outcomes? A head and a tail. So again, a head and a tail. A head, there are two outcomes, a head and a tail. If you want to think of this like a sample space, it was like here you would have listed, you rolled a 1 and then flipped a head. You rolled a 1 and then flipped a tail. You rolled a 2, then flipped a head. You rolled 2 and then flipped a tail, and you could go on and so forth. So that's how it's like a sample space from before. So again, each one of these would have a head and a tail, and a head and a tail, and again a head and a tail. So to count your possible outcomes, this would be 1, 2, 3, 4, and so on. So the fastest way is just to count the bottom. You have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12 possible outcomes. All right, you're going to try this. You are buying new eyeglasses and must choose the frames. The frame materials are plastic or metal. So that should be your first outcome. You should have a P and an M. Now coming from that, you would have a rectangle, an oval, cat's eyes, they're kind of pointed, or round. So you need to decide how many outcomes are coming off of there. There's 1, 2, 3, 4. So make yourself 4 outcomes coming off. And then we'll list them. I got a rectangle, an oval, a cat's eye, and I'm going to use a D for round. So rectangle, oval, cat's eye, and round. And then you read, comes in 3 colors, blue, black, or brown. Stop the video now and I want you to finish this. So I would have 3 outcomes coming off of each one. Blue, black, or brown. So then I would have 3 coming off of this one, and 3 coming off of this one. And yes, you would have to list them all out. Blue, black, brown, blue, black, brown, blue, black, brown, and 3 coming off of each of these. So if I had blue, black, and brown written on each of those, you can count the bottom. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 possible outcomes. The next one is the shortcut. If they don't need you to list them out and the directions don't say to list them out, you can use what's called the counting principle. You do not need to get this in your notes. Basically what the counting principle says, if there are m ways of making one choice and n ways of making a second choice, there are m times n ways to make the first followed by the second. So basically you are taking your outcome and you are multiplying it by your outcomes of the second one. And you are multiplying it. So you're taking the outcomes from the first and you're multiplying it by the outcomes of the second, and then you could multiply that by the outcomes of the third and multiply that by the outcomes of the fourth. So if you go back here for a minute, for instance, in this case, there were 2 possible outcomes. I'm going to do it in red. There were 2 outcomes for plastic and metal, 4 outcomes for the shape, and 3 outcomes for the color. 2 times 4 times 3 is 24. And this will always work. I can go back to the one before. I had 6 outcomes for my first choice and 2 outcomes for my second choice. 6 times 2 is 12. So for instance, here we have an ice cream menu. I have 5 flavors of ice cream, 3 flavors of toppings, and 2 flavors of cones. 5 times 3 times 2 is 30 outcomes. All right, you're going to give it a try. Good luck.